Can a coin flip truly be random? Or is there a subtle science at play that might predict the outcome? This question might seem simple, yet it forms the basis of statistical analysis and hypothesis testing. In essence, a hypothesis is a tentative statement or proposition that suggests a relationship between two or more variables. Imagine a scientific detective story with our hypothesis serving as the initial hunch. It's the starting point for our investigation, guiding us in designing experiments and conducting studies to test the validity of our proposed relationships. Now, we can't just jump in with any old idea. We need to classify our hypothesis. There are two main types, the null hypothesis and the alternative hypothesis. The null hypothesis is our skeptic, suggesting no significant difference or relationship between variables. It's the status quo that we're attempting to disprove. On the other hand, the alternative hypothesis is our maverick, proposing a specific difference or relationship that we aim to support. Let's dive a bit deeper. Our maverick, the alternative hypothesis, can come in three flavors: simple, composite, and non-directional. The simple alternative hypothesis posits a specific direction of the effect, like an increase or decrease in a variable. The composite alternative hypothesis is a bit more flexible, allowing for a range of possible effects without specifying a particular direction. The non-directional alternative hypothesis is the most open-ended, stating that there's a significant difference between groups, but not specifying the nature of that difference. Once we've formulated our hypotheses, we embark on a journey of hypothesis testing. This is a systematic procedure used to determine whether our skeptic, the null hypothesis, should be accepted or rejected. We'll choose a significance level, collect and analyze data, and finally make a decision about our null hypothesis based on critical values or p-values. However, there's a catch. In this process, we can make two types of errors, type 1 and type 2. A type Y error occurs when we incorrectly reject the null hypothesis, thinking we've found a significant effect or difference when there isn't one. On the other hand, a type 2 error occurs when we fail to detect a real effect or difference, incorrectly accepting the null hypothesis. Balancing these two types of errors is a delicate dance, crucial in hypothesis testing. Minimizing one type of error often increases the risk of the other, so researchers aim to strike a balance to draw accurate and reliable conclusions. So the next time you flip a coin, remember the complex world of hypothesis testing that underlies that simple action. In the realm of statistics and science, nothing is ever merely left to chance.